For those of you that don't know me, my name is Miss Quigley, and I teach with Mrs. McGowan. Today we're going to be doing a cool demo on separation techniques. I'm going to do it, I promise. I want to talk about this stuff first.
Okay.
So the first separation technique we're going to talk about today is going to be distillation. So when you have a solution that is a mixture and the components have different boiling points, you can separate them using distillation. Today we have blue Kool-Aid, and Mrs. McGowan is going to show us how she can separate those parts.
Pause it for a second.
No.
If you've ever been through Kalkaska, you know or you've seen the Pepsi Distillation Company, and you're like wondering, what is a distillation company? Well, this is a distiller, and a distiller separates water or another substance from a solute, like powder or something that's in there. And as Quigley said, we're going to separate our water from our sugar. So here I have the Bunsen burner, and it is heating up our blue Kool-Aid. And the blue Kool-Aid is starting to boil. So what's happening is the water is evaporating faster than the sugar, and you can see it's boiling pretty good here. And so what's happening is the water is evaporating, and as it evaporates, it goes through the distiller tube. I have water. If you can see these coils, the water is cooling down these coils here. And so it's cooling it down. And out here, we have pure water, good enough to drink. You could do that with apple juice. You could do that with really anything. You could even drink your own urine. In class, we're going to be doing a few different types of physical separation techniques. And so Miss Quigley is going to show us how to decant.
All right, so when your mixture has components in two different states of matter, you can use decanting as a quick and easy separation technique. So here I have solid sand and liquid water. So decanting is simply pouring off the top layer. So if you have something really picky, sometimes you can use a glass stir rod to help you. But with this mixture, it's going to be pretty easy to just slowly pour your top layer off. And then if you're really good at it, you'll have one container of water and one container of sand. I'm not going to totally finish. But this is the quick and easy way to get rid of solutions that you don't want when you're doing a lab.
Our next separation technique is filtration.
All right, so I just showed you guys decanting, which is how we separate by states of matter when we don't need to be super precise. We just need to get them separated. But if we want to get a better separation, you can use filtration, which you can think of like a coffee filter in your coffee pot. So when I pour my sand water into my filter paper, my solid particles are going to get stuck in the filter and my water will flow through. And it takes a while. So we'll leave it at that, but you'll see that at the bottom, we're going to get our water through and all the sand is going to stay in our filter paper. And the better the filter paper you have, the better the separation will be. Our next separation technique that we're going to talk about is going to be chromatography, and McGowan is going to demonstrate for you.
If you want to find out what a substance is made out of, you can use chromatography. I have a simple chromatography paper, which can be coffee filter if you want. And I put a small dot here. And because the makeup of this has different polarity, and we're going to be learning about polarity in class, it's going to separate at different rates. So what we did is we took that and we put that into water, and you can see the different colors, how they're separating.
All right, we're going to watch a quick video here that is going to give you real life examples of mixtures versus compounds, and it's going to talk about separating based on other physical properties.
I don't know if you caught that or not, but a very important thing is that new substance that's chemically combined has totally different properties. Remember that because that's important.